Okay, so basically the video cut out, so I'm just going to do it again. So at this point we're looking at sequence and series. This morning we were experiencing load shedding, so I'm just going to do the recording for these examples, and these examples are on page. We're looking firstly at quadratic patterns, combinations of arithmetic and geometric sequences. Okay, if you need the full lesson, will be found in the description box below. So example 1 is on page 25. It says consider the quadratic sequence, negative 6, 2 minus x, 4 and 2x plus 5. The question says solve for x. So since it's a quadratic pattern, or is a quadratic sequence, so that means to say it will have a second common difference. So what I do is I find the first difference, which is 2 minus x minus 6, which is 2 minus x minus minus 6. Okay, 2 minus x minus minus 6, which will give us minus x plus 8. Then we say 4 minus 2 minus x, which is 4 minus 2 plus x, which is x plus 2. And then we have 2x plus 5 minus 4, which is 2x plus 1. Okay, so that's my first difference. So let's look at my second difference. So it's going to be x plus 2 minus minus x plus 8. This gives you x plus 2 plus x minus 8. It's going to give you 2x minus 6. It's 2x minus 6. That will be 2x plus 1 minus x plus 2. Will be 2x plus 1 minus x minus 2. Will be x minus. Okay. So what we know what is exclusive to quadratic patterns is that the second common difference are equal to each other. Okay. So in other words, we have x would simply be equal to 5. So x is equal to 5. Alright. The next question says determine the nth term of the sequence, the series. Determine the nth term of the series. So what we need to do is we need to firstly work out the first 4 terms of the sequence. So wherever we see x, we replace it with 5. So it's negative 6, 2 minus 5, 4, you've got 2 times 5 plus 5. Which gives you negative 6 minus 3, 4 and 15. Okay. So as you can see here, for the first difference is going to be you're adding 3, then you're adding 7, then you're adding 9. Okay. Not 9, 11. Okay. So that difference is going to give us 4. So as you can see, there's a second common difference. So on the side we write 2a, 3a plus b, a plus b plus the bottom up. Okay. So if 2a is equal to 4, then a is equal to 2. Now we say 3 times 2 plus b is equal to 3. So b is equal to 3 minus 6, which is negative 3. And we know that a, which is 2, plus b, which is negative 3, plus c is going to be minus 6, that's minus 1. So c is equal to minus 1. So tn is equal to 2n squared minus 3n minus 1. And we'll be safe to check because the sum is normally worth 4 marks or more. So you say 4 times this test for term 3, you should get an answer of 4. Or if you test for term 4, you should get an answer of 15. There's 2 times 3 squared minus 3 times 3 minus 5. Gives you an answer of 4, which makes that general term correct. Okay, so that's Tn is equal to 2n squared minus 3n minus 1. Okay. Then I want to know which term, again I'm going to take this off so that I can keep the questions in focus. So now we are asking in question 3, which term has a value of 400? So the nth term is 400. So we've got 2n squared minus 3n minus 5 is equal to 400. Take 400 over the equal sign, becomes 3n squared minus 405 is equal to 0. quadratic equation, one of two things I can do here. Either use quadratic formula, or I can use this calculator. It's a nice program on here that allows you to factorize the quadratic. Okay. Otherwise, you can use the factorization, but that will take you further away from everything else. Okay. So let's go with mode. The mode equation is number 3 for quadratic. So it's 2, negative 3, and negative 405. That gives us x to be 15, or in this case n is equal to 15, or n is equal to negative 27 over 2. Of course, n has to be a natural number, so that's not the case. So therefore T15 will be equal to 400, which means to say, if we extend this pattern by 15 terms, the 15th term would be 400. So that basically brings us to the end of example 1. Let's look at example 2. Example 2 is on the same page. Example 2 is on page 25. Here they ask to evaluate the following. Evaluate, calculate, determine, simplify, all means the same to us. Okay. So we got 1, 2, 4, 5. Yes, I forgot to bring that down. Let's get it quickly. So this is the examples for exercise 10 on page 27. Examples for exercise 10 on page 27. Okay. So again, to evaluate the following, as you can see here, we have 1, 2, we don't have a 3, 4, 5, you don't have 6, 7, 8, you don't have the 9, and so on. So what you should note is that all the numbers, or all the factors of 3 is excluded from this pattern here. So it's 3, 6, 9, 12, 15, 18, and all the way. So 3, 6, 9, 12, and the last one, of course, that's divisible by 3 is going to be 99. As you can see, that is removed from this pattern. Okay? So if I add that to the pattern, my number pattern would simply read 1 plus 2 plus 3 plus 4 plus 5 plus all the way to 100. Okay? So what I'm going to do is I'm going to work out the sum of this pattern and then minus whatever we're going to get in the second sequence or series in this case, and subtract the 2. Okay. And as you can see, those numbers were removed. That's why I'm subtracting. Okay. So if you look at this pattern here we're adding 1 all the time. So this makes it an arithmetic progression. So Sn is equal to n over 2 into a plus L, since we have the first term and the last term. If you work out using the formula 2a plus n minus 1d, you'll get the same answer here. How many terms are here? So clearly we've got 1, 2, 3, 4, 5. So it's going to go to 100 terms. So S100 is 100 over 2 into a, which is 1 plus last term, which is 100. Okay. Let's punch that in the calculator. It will be 100 over 2. Oops. 100 over 2 into 1 plus 100 is 5,050. On the other hand, how do I move from one term to the next? I'm adding 3. Did you see that? So how many terms are here? It's the 1, 2, 3. So that's 3 times 3, or 3 times 2, 3 times 1, and so on. So in other words, there are 33 terms in this pattern. Okay? So again, this is an arithmetic progression. So S33 is equal to N, which is 33 over 2, into A, which is 3 plus L, which is 99. Again, you could use the other formula. So that simply give us 33 over 2 into 3 plus 99, which gives you 1683. 1683. So therefore, the sum will simply be, the sum of this series will simply be 5050 minus 1683. So that is going to be 5050 minus 1683. Gives you 3367. Okay. Alright, so again, the number 3 was removed from the sum of the series. Again, so I subtracted that. Okay. Now we're looking at example 3 on page 26. Example 3 on page 26. Example 3 on page 26. Okay. Again, we are asked to evaluate the following. We've got 1, 2, 5, 8, 10, 15, 16, and so on. So what you notice here is that 3 is not here, but there's 4, 5, 6 is not here, 7 is not here, 8, 9 is not here, 10, 11, 12, 13, 14 is not, and so on. So what you notice is that we won't be able to set a number pattern up using 3, 6, 7, 9, 11 and so on. Okay? Whoever's listening to music, it's very loud. Okay. So what I've noticed here as well is that if you look at this pattern, we got 1, 2, 4. So if I'm multiplying 2 all the time, then the next number is going to be 8. And the next number is going to be 16. And we know that 2, 5, 6 is part of that pattern. It's powers of 2. So we are going to break this up. So it's 1 plus 2 plus 4 plus 8 plus 16 plus 256. Okay. That is one pattern. If we look at the other pattern, we got 5, 10, 15. Of course, the next one is 20 and so on. And the last term is 260. So that's your second pattern. So as you can see here, we've got a 2-in-1 combination here. Okay. Which was added. Okay, so how many terms are here in this sequence? So what I do is I work out my general term. My general term is going to be a plus n minus 1 d. So it's going to be 2 to the exponent n minus 1. So that is 256 is equal to 2 to the n minus 1. So 256 is 2 to the exponent 7 or 6. I think it's 2 to the 7. Oh, 2 to the 8. So 2 to the 8 is equal to 2 to the n minus 1. So n is equal to 9. Okay, so what I'm going to do is I'm going to work out the sum of 9 terms since it's geometric. So Sn is equal to a r n minus 1 over r minus 1. Okay, so that will simply give us S9 is equal to a, which is 1, r, which is 2 to the 9 minus 1 over 2 minus 1. Okay, so that will simply give us 2 to the exponent 9 minus 1, which is 511. Okay. On the other hand, if you look at this sequence here, we're adding 5 all the time. Okay, so this follows a formula. Tn is equal to a plus n minus 1 times d, which is 5. So the nth term is 260 is equal to 5n. That of course cancel. So n is equal to 30 mathematical. So it's 260 divided by 5 gives us not 30, 52. Far from 30. 5 times 13 is going to be 65. Okay. But anyway, so this is arithmetic. Do we have our last term? Yes. So we can use the formula Sn is equal to n over 2 into a plus l. If I did not know the last term, a plus 2a into n minus 1d. So it's going to be 52 over 2 into a, which is 5, plus l, which is 260. Okay. That simply gives us 52 over 2 into 5 plus 260. That gives you 6,890. 6,890. But I never answered the question. No. Because remember, that's a combination of the two sequences. So I then say, yes, the series is total, whatever, is going to be 511 plus 6890. Okay, so 511 plus 6,890 gives you 7,401. 7,401. Okay. So that's that. Let's look at the next one. Example 4. That's on page 227. Okay. So example 4 on page 27, we are told that the first two terms of a geometric sequence and an arithmetic sequence is the same. Okay, so we got two sequences, we got an AP and a GP. AP, GP, so they're the same. Okay, the first term is 4. So if they're the same, that has to be 4 and 4. Okay, the first term is 4. The sum of the first three terms of the geometric sequence is 1 more than. Okay, just hang on. The sum of the first three terms of the geometric sequence, or GS, is 1 more than the sum of the first three terms of an arithmetic progression. Very important, that formula, that equation. Determine two possible values for R, the common ratio of the geometric sequence. Now I could have said the next term is going to be 4 plus D if it's arithmetic, and then this would have been 4 plus D because that's the same. But since they're asking with regards to R, I would rather than say that it's going to be 4R as my common ratio is, and because they're the same, that would also be 4R. Why is it the same? Because we have told you the geometric and the arithmetic sequence are the same. That is what I'm going on. Okay, so what would my D value be here? Let's just pull this down. So my A value, of course, is 4. My D value is going to be T2 minus T1, which is simply 4R minus 4. Okay. So with that information now we can say, okay, bring this into account now. Alright. It's down here, we don't need that information any longer. That is what we need now. Okay. So going with that information, to work out the sum of the geometric sequence, S3 is equal to A R n minus 1 over R minus 1. This is your Sn. Okay. With that information that we can draw from the GP here, your A value is 4 into R, which is R, the exponent 3 minus 1 over R minus 1 equals 1 plus. Now the sum of the arithmetic progression is going to be n over 2 into 2a plus n minus 1d. But now you're going to ask a question, why didn't I use a plus r? The reason for that is because I don't have my last term there. Okay, so with that information now I'm going and saying, okay, n is of course 3, so it's 3 over 2 into 2a, which is 4, plus n minus 1, which is 3 minus 1 is 2d. And what's my d is going to be 4r minus. Okay. Let's go again. Wherever I see a n, I'm going to put a 3. So it's 3 over 2 into 2a. Remember that is 4. Plus n minus 1, which is 3 minus 1 is 2. And your d value we're getting from there. Okay. So from here, it's just a bit of tidying up to do. Alright, let's just pull that down now. Let's take this off. So that's the difference of cubes. We've done that in grade 10. So the cube root of r cubed is r minus 1. We square the first term, gives you r squared. Negative r times negative 1 is negative r times negative 1 is going to be positive r plus 1 is the last term squared over r minus 1 is equal to 1 plus 3 over 2 into, that's going to give me 8 plus 8r minus 8. Okay, it feels like I made a mistake here. And I'll check now. So it's 1 plus 2 going to 2 1's 2 going to 8 4 times. It's going to give you 12r. That of course cancel, and that's what we wanted. It's 4 into r squared plus r plus 1. We get rid of the bracket, so it's 4r squared plus 4r plus 4 minus 12r minus 1 is equal to 0. So 4r squared minus 8r plus 3 is equal to 0. 3 times 4 is 12 is 6. Now I'm actually correct, surprisingly. I can work on my own with the help of the students. Okay, so that's going to give you 2r. 2r is 4 times 3 is 6. Both is negative. Okay, so r works out to be a half, or r works out to be 3 over 2. Okay. So what was the question? The question was, determine two possible values for r and the common ratio of the geometric sequence. Determine two possible values of r, the common ratio, okay. So, the question did not ask to work out the first 3 terms, but I can show you what the sequence is going to look like. And so it's going to be a half and 3 over 2. So take this into account. Okay. Let's look at the sequence. If we're going with, whoops, just need to align the board quickly. If r is equal to a half, okay, then for the AP it's going to be 4, 2, and then how do you move from one term to the next? I'm subtracting 2, so it's going to be 0. Okay, for the GP, as you can see, the computer is messing us around here. Let's just try again. Okay, so if r is equal to r, they're much better. This is going to, your AP is going to be your arithmetic progression, or your AS, arithmetic series, is going to be 4 sequence, sorry, will be 4. 2 times a half is going to be 4 times a half is 2. Then of course we subtracting 2 is going to give you 0. And for the GP, it's simply going to be 4, 2. Now I don't move from one to the next, I'm multiplying it by a half there. That's my geometry. Just have a look at this. If I add my AP, I'm going to get 2 plus 4 is 6, and this is going to give you 7. Not so. So if you work out that actually 7 is equal to 1 more than 6. You see that? Otherwise, you could have used the other sequence, and you'll see your findings will be the same. Okay. But as I said, this in black here is not required, as the question did not ask to determine the first three terms of the sequence. I just went a bit further for clarification's sake there. So at this point, you should be able to do exercise 10, and that's on page 27. That basically brings us to the end of this chapter.